Okay, our last lesson in statistics is going to take a look at confidence intervals and margins of error. So in this lesson, we're going to interpret statistical data using confidence intervals, confidence levels, and margins of error because we know that it's not always perfect or exactly on. Note that the focus will be on the interpretation of data rather than specific statistical calculations like we've done for the last 6 lessons. So in our previous work involving the normal distribution, we've determined means and standard deviations from populations. If we consider the question, what is the mean height of all the students in your school? We can determine the correct answer by measuring the height of every single student in the school. This would be the population mean. Because we're pulling from every student, then we would be solving for the exact average of every student. In practice, if the population is very large, we might use a random sample of students and estimate the population using what we call a sample mean. So we are going to be picking from, just say we had 2,000 students, maybe we would take from 500, maybe we'd take from 1,000, maybe we'd only take from 100 students because that's all we had the resources to do. So when it says how confident would we be that the sample mean and the population mean are the same, well, when we take the data from a sample and calculate the sample mean, we can never be sure that the sample is going to be the same as the exact population. In fact, it would be rare occurrence for the sample to be the exact same as the population mean. The best that we can hope is the sample mean will be close enough that it is working data. We can determine a range of values around the sample mean in which we can be reasonably confident that the population mean lies. For example, if the mean height of the students is 67.5 inches, we can't be sure that that is going to be the population mean. That is just for that sample of students. But if we said that taking a sample and said that 67.5 inches was there, we can be reasonably confident that all the students, or the average height of the students, will lie between 65 and 70 inches. We can be even more confident that it would be between 63 and 72 inches. So the range of values from 65 to 70 inches is called the interval. In this case, the interval would be the average that we solve for, either plus 2.5 or minus 2.5, which means that we have given a 2.5 inch margin of error. So we could be off from the average or mean by 2.5%. If the range of values from 63 to 72 inches are also an interval, then I would say, well, how much above 67.5 and how much below 67.5 would this be? Well, I could just take my average that we solved and take away what the lower one is. And I'm going to state that that would be, if that's 3.5, then my margin of error is going to be 3.5 inches. So I'm saying that it could either be 3.5 inches below the average or 3.5 inches above the average. We will be more confident that the population lies in between this than in this because it's accounting for a wider range of values. The level of confidence that we have the population mean lies in a particular interval is called the confidence level, as is usually given as a percentage. The interval is the confidence interval. So if I'm saying what is the confidence interval would, for these cases, be like 65 to 70. That's the confidence interval, or the range of data that I'm looking at. If I said that I am 80% positive that this is correct, the confidence level would be 80% likelihood that the data is going to exist in between these things. So, if we consider the following question, what percent of Canadian voters would vote for the Conservative Party in the next election? It is not practical to survey the entire population of Canadian voters, and so we just take a sample. A polling organization conducts an opinion poll whose aim is to determine the percentage of Canadian voters who would vote for the Conservative Party, and they release the following statement. In the poll, 38% of Canadian voters said they would vote for the Conservative Party. The results are accurate within 3.5%, and that is true 19 times out of 20. In this example, we'd use the sample portion, 38%, as an estimate of the true proportion of Canadian voters who would vote for the Conservative Party. The margin of error in this case is the possible difference between the sample estimate and the true population portion. So in this case, if we have a 3.5%, then it would range from 3.5% below this, so 34.5% of people, all the way to 41.5%, which would be 3.5 above. That is our confidence interval. The confidence level is the likelihood that this is correct. In this case, they said that 19 out of 20 times this data would be correct, which means that it has a 95% chance of being within that confidence interval. So there's a 95% chance that the true amount of voters would be between the 34.5% and 41.5%. If we put this into practice, we're going to state that in order to determine the mean mass of golf balls produced at a factory, sampling is done and the following statement is made by the company. The mean mass of the golf balls produced at our factory is 45.6 grams with a plus or minus 0.3 grams. The results are accurate 19 times out of 20. So the first thing, if we're determining the confidence level, that is the percentage of likelihood that our data is correct, well, if it says it's 19 out of 20, 19 divided by 20 times 100 is going to give you my percentage. It's 95% likely. If I'm determining the confidence interval, I'm going to say that on the left, it's going to be 45.6 minus 0.3. And that's going to go all the way to 45.6 plus 0.3. So I'm going to say that's going to be from 45.3 grams to 45.9 grams. That is the area which it is going to fit. What is the margin of error? Well, the margin of error is that plus or minus 3 grams. The margin of error is 0.3 grams. Is it likely that the mean mass of a golf ball produced in this factory is going to be 45.1 grams? No. This does not fit within the confidence interval where 95% of the data should lie. which means realistically there's only about a 5% chance that it's going to exist outside of that area. Is it possible that the mean mass of golf balls produced in this factory is going to be 41.5%? Yes. There will never be a 0% chance. That's why we always have the confidence level. As much as our data will likely fit into this area, and in some cases extremely likely, it's never going to be a for certain, oh, well, this could never ever happen. It's the same as like the mean height of students in a school one year. Well, is it likely that it would ever be 6 inches shorter than the year before? No. But is it physically possible? Yes.